Okay, so today we are going to start talking about matrices and some basic operations with those. All right, our learning targets to understand what a matrix is and how to use them to display mathematical and real-world data, and then do some operations with them as well. All right, let's pause here as we ignite. All right. How are matrices used to display data, and what the heck are they? So what does a matrix look like? This is a question posed in the movie as well, but really a matrix just looks like this. And it displays data, and usually your simple like spreadsheet is kind of an example of a matrix. And so you have entries in here, and then you have rows and columns, and we're going to talk about how those work and how we name them. So all right, one of the reasons we use matrices is to display lots and lots of data because it's easier. So here would be an example of something a little bit more scaled down, but where you might start to put something into a matrix. It says a theater is doing a Marvel Day and showing Captain America Civil War, Avengers Infinity War, and Avengers Endgame. Here are the ticket sales for the first day. Captain America Civil War, 423 adults, 135 students. Infinity War, 683 adults, 350 students, and Endgame, 675 adults and 360 students. So here we can arrange this into a matrix to represent some of these things. So that first line, this is Civil War, this is Infinity War, and this is Endgame. Okay, and then this here is the adult, and this is the student column. So that's how we can use that to start to display some of these. And obviously, if you are a business, you're going to have much more columns and rows in there. Okay. Now, a little bit about these types of things. So first of all, we use a capital letter for every matrix. So this is matrix A. You'll notice it's a capital letter. And our dimensions are M by N. So we always say the M is the rows and the N is the columns. And we'll talk a little bit more about that in a second. But this then would be a 2 by 3 matrix because it has 2 rows and 3 columns. Okay, and then the entries are each of these values in the matrix. So this is, each of those is called an entry, and they have a specific location. We call that an address. Okay, and the address is going to be denoted by the row that it's in, followed by the column that it's in. So this says A sub 21. So that means 2 represents the row 2 and 1 represents column 1. Okay, and again, we'll talk more about that here in a second. All right, so as I just said, the dimensions of a matrix are M by N. And let's dive into that a little bit further. We always state this would be your rows. Okay, and this is going to be your columns. Okay, so you're always going to state the dimensions of a matrix by the rows first and then the columns. Okay, so if we take a look at these, what are the dimensions of each of these matrices? Let's pause here to identify those. Okay, this would be a 1 by 3. This here would be a 3 by 4. This one up here is a 2 by 6. And this would be a 4 by 2 matrix. Okay, hopefully that makes some sense. All right, let's move to elements. Remember, matrices are named with a capital letter. So here's another matrix, matrix A, and we have a bunch of elements. and each are located in a specific spot. Now, this first one, you'll notice it says, oops, A, notice it's a lowercase a to represent the address. So it'll be the same letter as this. And then it says sub 25. So what are what entry is in the position A25? And let's go through and look at each of those, what those might be. We'll pause here. All right, so for each of these, our entries, this would be -2, this would be 40, 21, 5, 52, and 32. Again, A25, so if we look at that first one, that means the 2 represents the row that we're in, so that would be this row. And the 5 represents the column that we're in, so that would be this one. So where do they cross? That's this right here at -2. So that's how we got that again. Okay. All right, so those are positions of different things. A couple of different things. In order for 2 matrices to be equal, they have to be exactly the same dimensions and identical element by element. In other words, that this would have to equal this in order for these to be the same. And this entry would have to equal this entry. They are both 2x1 matrices, so they have the same dimensions, but they have to be exactly the same elements in order for them to be equal. Okay. All right, now, adding and subtracting matrices. So you can add and subtract 2 matrices, but you can only do that if they have the same dimensions, exactly the same dimensions. So for example, on the left here, I can add that 1, 2, 6, 7 matrix to 2, 1, 7, 6 matrix because they're both 2x2s. And I could add that 5, 6, 7 matrix because it's a 3x1 to that other one that's also a 3x1. However, I can't add them if they have different dimensions, like over here. The first one is a 1x2. I cannot add that to a 2x1. Okay? And how do we add them? You simply just add each element, corresponding element. So if I want to say, what is W plus Y? I am going to just go 3 plus 8 and put that in the same spot. Okay? And then the next one would be -7 plus 3, and that would go in the same spot. Okay? And then 4 plus -10 would be -6, and then 5 plus 12 would be 17. So again, this is a 2x2, this is a 2x2. This dimension, these dimensions have to be the same. So 2x2 or a 7x4, I could add to a 7x4. Okay, and then your answer would be the same dimension. So this one, well, our answer, notice, is also a 2x2. And that's adding. Subtracting works the same way. You're just subtracting. Just be careful of the negative signs. So for example, if I go 5 minus 4, minus -10, just be careful that you're minus a -10, so that would actually be 14 if you're subtracting those 2 matrices. Okay, so then lastly, we can also, last thing we're going to talk about today is scalar multiplication. So matrices can be also multiplied by a constant. This is called a scalar. And when you do this, each element in the matrix is multiplied by that scalar to produce a new matrix. So I have a couple of matrices here, and it says find 3p minus q. Okay, scalar multiplication, pretty easy. So really all this means is we're going to go 3 times this whole matrix p okay, and then we're going to subtract q. And q is 704 3, negative 9, 6. Okay, so when you do scalar multiplication, all you're going to do in this first one is just take 3 times everything in that P matrix. So this is going to become 12. So again, 3 times 4, and then 3 times negative 2, so negative 6. Then 18, 24, negative 3, 21. And then we're going to subtract 7, 0, 4, 3, negative 9, 6. And this will give us our answer matrix. Again, it will be the same dimensions. Those 2 matrices we can subtract because they are both 3 by 2 matrices. So we're good. All right, so 12 minus 7 is 5. Negative 6 minus 0 is negative 6. 18 minus 4 is 14. 24 minus 3 is 21. Negative 3 minus negative 9, so that's really negative 3 plus 9, which would be 6. And then 21 minus 6 would be 15. Okay, so this would be 3p minus q. So that's scalar multiplication with also some subtraction. And that's it. It's everything you need to know about our matrices to begin with, basic operations, and just an introduction. So what I'd like you to do is try this assignment now. Go back and watch any parts of this video if you're confused. All right, good luck.